buzz bars for drilling. Just basically a couple of nuts and bolts through the holes, clamp half the buzz bars together, because you get away with drilling half the buzz bars. Just a matter of drilling a hole in the centre of the buzz bars there. So let's set up, drills in, down there. There we go, simple as that. Using a drill press keeps it all at 90 degrees. The two bolts are sat on the floor, so that's flat there. Drills a hole right through at 90 degrees, and that's what you want. You don't want your nuts or screws off on angles, because if you do that, what's going to happen is your nuts, your screw's not going to sit down nice and flat on top of that balancer lead. Okay, so that's it. Right, let's get back to the workbench. Right then, guys, when I say workbench, I mean it's a newly fitted kitchen I've fitted in. So I'm using this as a workbench. I've got my workshop. The workshop's back where the drill press is. That's coming on. I need to get me lithium batteries set up. Get my iron lithium batteries set up. Right, so it's just a matter now. They've all been drilled. It's tapping them. This is the tapping method I'm using. Right, so what we got, I've already done a load here. One there that's been done. It's an M3 tap on a ratchet fitting, just like that. Ratchet in, ratchet out. And I suggest you don't try and do it fast. You just a matter of starting the tap off, just like that. You can just feel it biting now. As it bites, because it's only 2 millimeters thick, there aren't any through. Okay, that's it. Then just a matter of spinning them off, taking a nut, bolt, and just screwing them in there just to make sure he's okay. That's all good. Checking with the finished ones. Same again. Whoop. Try and keep them as straight as you can. There, he's biting there now. There, he just broke through there. That's him. Get the screw. Yep. So that's basically it. Right, I'm sure you don't want to watch me do all the rest of these, so I'll stop you off there, and we'll go and have a look at the batteries, shall we? Okay guys, iron lithium batteries. This is the first 48 volt iron lithium 280 amp hour battery pack I got. 16 cells, 3.2 volt nominal voltage. That's what they come at from the supplier, because it's dangerous to ship them fully charged. So they ship them at the lowest voltage that the batteries will withstand. So what we need to do is boost that charge up to somewhere around 3.5, 3.6. They've got the 3.6.7, I think it is. So yeah, up around the 3.6 to 7 mark as individual cells. So as you can see, I've got them all paralleled up with the buzz bars that I'm using, the copper buzz bars. I've tapped the center of the buzz bar, so I can get all my balancer leads on. So that's working. The charger's set at, you can't go by the readings on the actual charger, because you set the charger to 365, and for some bizarre reason it drops down to 345, but as it charges that figure comes up. When it hits 365 it stops charging, so that's how it works. Banging in 1.6 amp, no, sorry, 16.3 amps. It's a 80 amp charger, so shouldn't take too long, couple of days maybe, not really sure. 280 amp hour, so it's a fair old whack of batteries. So anyway, that's it. I number all my cells, so as soon as I get them I'll check the voltages and put a sticker on saying what it is. That's battery A, number 1, battery A, number 2, battery A, number 3, and so on. The other battery that's still in boxes at the back there, another 48 volt, 16 cells, 3.2, 280 amp hour. They're resting there at the moment, and that's battery B, obviously. That's where the other battery is going to sit in there. So that gives me 2 lots then. I've mounted all the getting ready to start mounting all the electrical bits and pieces on it. This is where the battery management system's going to sit. I've got 2 battery management systems. One's going to be here, one's going to be here, and this is for the displays. There's one display here and one display there, which will show through 2 holes in the steps. So I'll get on with fitting that and show you what that's like when I fitted it, and we'll go from there. But right then, guys, this morning we're working on the lithium battery. It's given me a chance to tidy up these cables a bit, get them wire tied in. I've already sorted out some of the back 4, or the back 8. So just sorting out the balancer leads for the front 8 now. What it was when I originally done the battery, I could only find ring crimps, 1.5mm ring crimps, which weren't adequate really for, or weren't the right size for the cables I got, because the cable on this here is 0.5. okay, and if your cable is 0.5 then you should be using 0.5mm ring crimps. Okay, so it's caused a little bit of a problem, actually. A little bit of a problem. It's not too bad, but what it's done is you get a little bit of slack on the, I don't know if you can see me here, when you pull the cable like that, you can feel a little bit of wriggling on there, and that's given us a little bit false readings on the readings on the balancer. So just to get it exactly right, I need to get them set up and make sure in my own mind that it's done right. That way we can guarantee the readings that we're getting and what's feeding back to the charger, and the rest of it is all okay. That's me. These here are 4 temperature sensors which will go to the batteries, just tidying them up. A couple of wire ties, get them a bit clean and tidy so we can figure out what we're doing here then. Yeah, I dropped my glasses on the grass outside, and somebody delightfully come along and scooped them up with a grass cutter, so I need to sort out a new pair of glasses, but I think I can manage. Right, so where are we to? a little bit of play on that one. Right then, so let's start. Okay, so basically what we've got is we've got 48 volt battery. It's 16 cells of 3.2 volt nominal, up to 3.7 the voltage for each one of these cells, compressed in a box. Compressed in a box. Compressed in a box. Connection buzz bars. Center of the connection buzz bars is a 3mm hole tapped in a copper buzz bar, and then we got our balancer leads fitted to the center of the buzz bar, so that gives us accurate readings, or as accurate as we can get. Right, so what I'm doing is changing the 1.5mm ring crimps on here, and as you can see, it's quite a dinky little screw. So all we're doing is we're cutting off that one. That's the 1.5mm one. I know a lot of you might be screaming at the screen to see me peel that off with a pair of side cuts, but I've got a pair of these, but they do tend to take a bit of copper with them when they peel off. So being that I'm confident that I'm getting the full amount of copper left on the wires, you're not breaking any wires off when I'm doing it. They go in like that. Make sure the wire's there, crimp him, peel him off. There, no movement in that one now. It's just a matter of taking this one. It's going to be the front 6 or front 8. Put that one back onto there. You'll have to bear with me. I'm doing it mostly by feel because I can't see a thing. That's a good connection, so we're happy with that one. On to the next one. And like I've said before, with a 48 volt lithium battery, you do have to have a little bit of respect for it, because it can hurt you. So always make sure you're confident in what you're doing. Yeah, always make sure you're confident in what you're doing when you're doing electrics, because it can hurt. It can damage yourself quite severely. So it's possible to do it yourself, and you know, so you're confident and you keep your wits about you. Other than that, it's just repetitive work, double checking everything you do, getting everything set up. A few techniques you need to learn sometimes, but nothing you can't pick up from YouTube, so it's other than that, it's just being very careful and realising that you can touch these batteries with both hands, no problem there, but you don't go anywhere near them two there, because that's your full 48 volt coming out of there. You don't want to go slamming a spanner or metal object across it. Stay away from that as much as you can. But back here you got two there, or one there, that could cause a problem, but providing you you know, it can't hurt you just by touching it, but it can if you touch a bit of metal on it or anything like that. So yeah, just be wary. Right, next one's here at the front. No, it's not, it's over here. This one next. We'll do them as we go down, I think. That's that one out. There we go. Turn them off a bit, maybe. Try that. Might make it a bit easier. Give it a go. Oh, that's not too bad. That wasn't too bad. Just turn the pressure down on them a little bit. Now, there you go. That makes it a bit quicker, a bit easier, a bit more precise, maybe. Of course, losing my glasses did now. Losing my glasses to the chomp up lawnmower, eh? Never mind. You win some, lose some, don't you? It feels a bit donkey there. Let's try that again. That's got him. Doing one at a time, because then you're not going to get messed up. I went through, I got a video somewhere of when we set them up and how to check out the to make sure you got it before you. The balancer leads have to be set in a specific way. It's not just any cable anywhere. You've got to be set up properly. I've done a video on it. It's a Cepos battery management system I'm using. Best on the market. A lot of these big metal boxes you're buying have the Cepos battery management systems in them. So it will run. Yeah, good system. And that's the system I'm using. I've only got the 148 volt battery up and running at the moment. The others are under the bed. I've set them up and I'm top balancing them. So to top balance the 48 volt battery, I do them in two 24 volts. Basically because the chargers I've got aren't that big, so it's easier to charge a 24 volt battery than a 48 volt battery. So I put them all in parallel. So basically these here will be neutral to neutral to neutral, neutral all the way down through, live all the way down through. So you've got a 3.2 volt cell, and then a 3.2 volt cell, and then you charge them all up 3.6. So bang, charge them all up 3.6 volt, and that is how they're done. That's 224 volt runs. Then I take the 224 volt runs and I turn it into a 48 volt run, so that's linking the two batteries together, and I just top charge it again, let them settle, and then top charge it again, so they're all up to 3.6, all balancing at the same level. And then when I'm happy with that, I let them rest a couple of days, and I split them down and put them in series to make up 224 volt batteries. Once I've made up the 224 volt batteries, I put them in, well, so obviously I put them in place, like here. They're in place. And then not until the very last minute do I put the bridging bar in there, the link bar there, to join the two batteries up into a 48 volt battery. That way you're cutting down the chance of hurting yourself working on a 48 volt battery. Okay, so that there. I've done a couple of videos on it, so I'll put it all in this lithium battery build video group, and hope it helps you with the information you need to know to build your iron lithium batteries. So that's that group up there. So the next one's this one. Yeah, so I mean, the battery was working okay. I just felt in my own mind that I know I used 1.5mm ring crimps on it, and it should have been 0.5mm ring crimps, so I'll just come back to it and set it up properly. Even with the 0.5mm ring crimps, I'm bending the wire over because I can quite easily get the bent over wire through there. So it's, they're quite small cables, these ring crimps, but that's nice and solid. Happy with them now. Every time I switch the battery on or fire on a load that's putting the battery to its maximum load, I can feel happy that it's not going to let me down. One of these ring pulls, they're ring crimps. So it's, as I say, I'm doing most of this by feel. I can't see a thing really, not close up. Long range I can. And if you're starting your venture out on the lithium battery trail, you buy any tools to work on it, try and get insulated tools, so all the handles, all the bits are insulated, so reduces the risk of shorting anything out, yeah. And the other thing's a good thing to have is a nice plastic box to put all your crimps in and all that gear, because you've got it all on hand. You can all your ring crimps in one box, all your spade terminals and all the rest of the stuff you use in another box, and it's easy to choose the right right kit for the job. And it, for me, living in France for 25 years, I wasn't too sure where to get the gear until I came across Toolstation. Did I know where to get all me just going to tie them up a minute. Did I know where to get all me bits and pieces? Toolstation, I thought they just sold tools. They don't, they sell everything, the whole bit. I would say I get 75% of my gear now from Toolstation. So, good idea to make an account at Toolstation, and I made a few mistakes as I went along. Oh no, I don't bother with an account or anything like that, but I had it done, and I think I would have saved a few quid. Not a vast amount, because I'm quite a tight fist really. There we go, that looks better, doesn't it, eh? Right, yeah, so we've done that one, this one next. Right there, tangled you. Right. Yeah, so yeah, I think I've said before, but yeah, system I'm using is a grow watt inverter, 5 kilowatt grow watt inverter, well over. I could have used the 3 kilowatt one for what I need, but when I was looking at the 3 kilowatt one, I looked at the 5 kilowatt one obviously. The 5 kilowatt one was around about the same price as the 3 kilowatt one really, and it had a couple of extra little bits and pieces on it, so I thought, well, why stretch a 3 kilowatt one with yeah, why stretch a 3 kilowatt one when I can use a 5 kilowatt one and not overload it. So the theory on that was basically If you need 3, get a 5, and you're not asking it to do more than you need it to do, basically. So that's that. Beautiful. I'm 100% happy with that now, whereas before I wasn't. It's always in the back of your mind, wasn't it, when you do something that you shouldn't do. And that old narrowboat electrician keeps saying, use the right size ring crimps. She's quite right in saying, but every time he says it, it always takes my mind back to this battery and these ring crimps here. So now he says it, now when he says it, I can say, mine's the right size. Yeah. Although I ain't got 1,000 volt going through them, he's only about 1.2 volts, something like that. Not sure. Anyway, yeah, it's still not right. And just the way they're feeling as I crimp them and tug on them at the end. But they're nice and solid, just a job. I'm happy with that now. That looks nice and tidy. I know it's a bit of a faff as well when you look at these batteries. When you look at those batteries in a tin box, it's just a tin box, drop it on the floor, plug your RJ45 into it, wire it into your buzz bar system, and there you got another 200 amp hour of battery power, which is okay. But when I actually started thinking about powering my narrowboat, which was a couple of years ago I suppose, when the project first kicked off, thinking about it anyway, iron lithium was quite a newish thing, quite a sort of thing that everybody's saying stay away from iron lithium, they catch on fire. And I used to, well, I still am, I do a fair bit of aero modelling, flying, and we used to use P&B cell batteries to power our model aircraft. And iron lithium come in, and I had a Grumman Panther ductive fan, iron lithium, one of the early ones, very early ones, and I remember it nearly catching fire on a landing once when I came in, overstretching the batteries. They got a bit hot, and we managed to get the battery pack out, but it virtually caught fire on the grass. It went off for about an hour, hour and a half. I suppose it was sparking and jumping about all over the place. So yeah, that gave me a rough grounding on iron lithium. So, but in this day and age now, with the correct battery management systems, that's where it's okay. Make sure you get this battery management system up and running and in place, and little details like these crimps and stuff like that, providing you do that, providing you educate yourself on what you're doing. Educate yourself on what you're doing. Watch some YouTube videos. If you want to watch a really good YouTube channel on iron lithium batteries, or this style of iron lithium battery, what they call DIY iron lithium batteries, go to a YouTube channel called Ray Does Cool Stuff. Ray Builds Cool Stuff. I think he's Canadian, not sure. He's out there in the sun anyway somewhere, and he's building LPO4 lithium batteries, and I got a lot of information from him. and yeah, really good tutor on the lithium. Really worth a good watch. So and don't forget to subscribe to these guys, and don't forget to subscribe to me. It's like and subscribe, they say. Good morning, guys. Well, the iron lithiums are now up and running. That's the I'm playing with the inverter, not really on top of it yet. Still got a lot to learn about the system and how it works, but it's all running nicely. It's on float charge at the moment. As you can see, we're 1, 2, 3, 4 bars up, which means it's fully charged as far as the inverter is concerned. But I need to tell it that it's a 280 amp hour battery and not a 150 amp hour battery. At the moment it's treating it like a 150 amp hour battery. I don't know why, but we're going to have a look at that. I think I've got to charge the battery up, maybe, I'm not sure, and then connect it, and then it knows what it is. But anyway, that's to be discussed. I'll go through the system I've got here. This is my you got there, what we got at the moment. That'll give you some idea what the weather's like. Really overcast and cloudy and not very nice at all. Okay guys, sorry about the noise of the cars. That's the solar panels on. So you go down through, we'll have a walk down. That's the panels. Special brackets printed there for the centres. Already getting a mobile phone signal, and we're getting 73.8 volt from my panels. That's 2 panels coming in, so that's only measuring the 2 panels, because what I've actually got on is I've got 420 watt 37 volt solar panels, and I've got 4 of them. 2 of them in series. That gives, because I needed to get the 37 volt above or up to 48 volt, because you need to feed this inverter with, because I've got 48 volt batteries on, it needs to be a minimum of 48 volts coming in. So there I've got 73 by putting 2 in series, and then I've got the 2 in series coming in here. That's the 2 negatives, 2 positives. That's going in then to negative, positive there, so that's giving me 840 watts, 840 watts of energy coming in, and then I've got shore power up there coming in. That comes in through my galvanic isolator, and then it goes into a 50 amp breaker here. That comes in through there into the breaker there, comes out the breaker down on the side here, goes down this black tube through these cables here, down to the inverter. That goes to the AC in to the inverter, and then the AC out of the inverter goes back through those grey cables, comes back up through here and goes into this 100 amp breaker here. This inverter is capable of putting out 260 amp. So it goes into a 100 amp breaker there on the AC side, that is, then which in turn goes into a 63 amp breaker there, and then I've got 40 amp there which has got to come out, and a 16's got to go in there, and I've got a 16 there and a 6, and then I've got a 6, a 16 and a 16 there, to another 63. So I've got 2 lines ready. left hand side of the boat, right hand side of the boat, the 40 amps coming out, and I'm putting a 16 in there because all I'm going to ever need is a 16 amp. So and that does us two each side of the boat, 240 volt power. So I've got 240 volt one side, 240 volt the other side. That sets all that up nicely. Everything's done in conduits, as I've said before, right throughout the boat. So if I need to pull anything out, push anything in, that's how it works. Solar shut off switches there, just a shut off switch, all fused in line. We've got 15 amp fuses on all the panels coming in, so they're all individually fused before it gets here. That's a shut off switch, as I say, to shut off anything going into the inverter. And as you know, you need to shut your solar off first, then your 240, then your battery, and then to switch it back on, use your battery, your 240 volt, then your solar. Down here, that's the cables coming in. They're 70 square millimeter, not sure, anyway, yeah, big cables come into the buzz bar system. There's the buzz bar system here. Anybody's wondering what this is, that's basically a resistor. That resistor is there, so when I'm connecting up anything to this positive buzz bar like this, the first time I set up the connected it to the inverter, I used this cable here to connect to the power through that resistor. Basically the reason for that is I don't want to blow up the capacitors in the inverter. Okay, so any electrical component I'm connecting to the system, I touch on there first before I connect to the buzz bar. So if I have let's say a DC charger controller on a separate battery somewhere, then I can, like in the engine bay, I'm going to have a 48 volt battery running off the alternator in there. That's going to have a DC charger outlet thingamajig. I'm not sure what I'm going to connect up to that yet, but I can bring me 12 volt lead acid into here before I connect it up to this system. Touch it on there, it loads up any capacitors that are in any controllers or whatever before you touch it onto that 48 volt system, because sometimes if you bang it straight onto a 48 volt system you get a big spark and it'll less swell if not blow up the capacitors on your board. So that's the reason why it's there. And GrowWatt suggests you put one in, so that's what it's there for. Anyway, that's the negative buzz bar system. Positive buzz bar system is the shut off switch for the 48 volt battery under the stairs, and that's the shut off switch which is going to be for the second battery that's going down here, and then there'll be a third one in the middle here if I decide to put one on top. So that's basically the system as it is. There's the earth lead coming from the earth buzz bar up here. That goes down into and is bolted to the engine bed, which is connected to the frame of the boat, or the chassis of the boat if you want to call it that. And then the earth comes from there up onto the engine. So any earthing or neutral systems there goes onto that. So it's all linked up. So if I get any faults on the 240 or on the generating side anywhere or whatever, it's all protected by earth, as it should be. As it should be. Okay, so that's basically the system. Or as when I say as it should be, I'm not a qualified, trained, fully skilled electrician. I've done a fair bit of electrical work with different guys, but yeah, I just follow their lead, and as from what I can understand, there's quite an in-depth argument about earthing boats and one thing and another. Basically, I've gone down the route and listened to guys that supposedly know I'm pretty sure they know what they're talking about, so that's the route I've taken. So I'm fully earthed down and galvanic isolated as well. So yeah, anyway, that may cause a few comments. If it does, then great. It's good to have open discussion on anything that I've done here, because you know, I try to keep it as safe as I can, as good as I can. So yeah, hope you liked the video on the iron lithium batteries. Hope it's taken a bit of fear away from people that may have had the fear of iron lithium, to watch an idiot like me banging around with it. So I haven't blown myself up, caught myself on fire yet. So yeah, investigate it. It's a good system, and when it's sunny up there, it's all free, and that's the bit I really like. Okay, anyway, have a good one. Subscribe, and press that like button if you like it, and see you on the next one. Bye.